Welcome back to Science and Slumber, the quiet corner of the cosmos where curiosity and calm meet. Tonight, we're going on a slow, soothing journey. We are going to follow a ghost. Not a ghost of folklore, but a ghost of gravity, a silent wanderer cast out from its home. We're going to ask a simple question. What happens when a black hole, one of the universe's great anchors, breaks its chain and goes rogue? Where does it go, and what stories does it write in the dark? It sounds simple, almost like a cosmic fairy tale, but the deeper you fall into it, the more you realize it is a story about the unseen currents of the universe, about exile, and about the immense power of a single lonely object drifting through the void. I hope this story helps you drift off into a deep and peaceful sleep, or, if you prefer, I hope it keeps you pleasantly curious, floating in a state of gentle wonder. If you feel you have a moment, and you can, a simple tap on the like button and perhaps a quiet click on subscribe really helps this sleepy little channel grow, reaching others who might need a calm voice in the night. So, just for now, settle in, get comfortable under your blankets, let go of any thoughts from the day, and give yourself permission to simply be here. There is nothing to figure out, nothing to achieve. Just let the words wash over you, like the soft, cosmic background hum of the universe itself. Ready? Here we go. To understand the journey of this lonely wanderer, we first have to understand the road it travels on. We are taught to think of space as a vast emptiness, a black, cold, vacant stage on which the stars and planets perform their silent play. But that isn't the whole story. The truth is far more wondrous and far more intimate. Imagine for a moment that space is not a void. Imagine it is a substance, a medium, like an ocean of perfect, profound stillness. Picture yourself floating in the center of this cosmic ocean. There is no up or down, no surface or floor, only infinite, gentle depth in every direction. It is not made of water. It is made of something far more fundamental, the very fabric of reality itself. It is perfectly transparent and utterly silent. You feel it around you, not as a pressure, but as a presence. It is the medium that holds everything. This is space-time. It is the arena of existence, and it is not empty at all. It is a thing in itself, a deep and patient entity that bends and stretches and ripples. Now, let us reconsider gravity. In our old picture of an empty stage, gravity was a mysterious force, an invisible rope reaching out across the void, pulling objects toward one another. But in this new picture, in this deep and silent ocean of space-time, gravity is something far more elegant. It is not a force at all. It is a shape. Imagine placing a heavy, sleeping star into this substance. The star doesn't just sit in it sinks in it, pressing down, creating a gentle sloping curvature in the fabric around it. Like a heavy ball resting on a soft, stretched sheet, it creates a dip, a well. This dip, this gentle valley in the substance of space-time, is gravity. An object, like a small planet drifting nearby, isn't being pulled by a rope. It simply encounters this curve in its path. And like a small marble rolling near a bowling ball on a trampoline, it begins to follow the slope. It glides gently into an orbit, perpetually rolling along the soft, curved walls of the valley created by the star. The planet thinks it is moving in a straight line, but the very road it travels on is curved. It is the shape of the universe itself that guides its motion. In other words, gravity is not a command shouted across the void. It is a whisper embedded in the path itself. It is the quiet geometry of the cosmos, a passive and graceful influence that shapes the dance of worlds. There's something so peaceful in this idea, isn't there? The universe isn't governed by aggressive pulling and pushing, but by patient, yielding curves. When Albert Einstein first imagined this a little over a century ago, he gave us a new way to feel the cosmos. He saw that the stage and the actors were one and the same. Our Earth is not tethered to the sun. It is simply following the most natural, effortless path through a universe shaped by the sun's immense presence. This ocean of space-time is where our rogue black hole will make its journey. It is a traveller moving through this deep, responsive medium, but the curve it creates is no gentle valley. It is something far deeper, a well of almost infinite steepness, and to create a curve that profound, you need more than just the quiet weight of a sleeping star. It begins with the last, silent breath of something immense and brilliant. That profound curve begins with the last, silent breath of something immense and brilliant. It begins with a star, but not a star like our Sunday. Imagine a giant, a true leviathan of light, hundreds of times more massive, burning a fierce, incandescent blue in the darkness. For millions of years, this star is a glorious engine, a cosmic furnace whose heart is a roaring fusion reaction. Its entire life is a perfect, delicate balance. The outward press of its own light and heat, a constant, radiant explosion, pushes against the unyielding inward pull of its own colossal gravity. It is a giant holding its breath, a state of sustained, magnificent tension, but this breath cannot be held forever. Deep in its core, the star has been forging heavier and heavier elements, turning hydrogen to helium, helium to carbon, and on, in a desperate creative act to keep its fires burning. Eventually, its fuel runs out. The furnace in its heart begins to flicker. The outward push, the radiant pressure that has held its own immense weight at bay for eons, begins to soften. And gravity, the patient, ever-present force that has been waiting all this time, finally begins to win. There is no great battle. There is only a surrender. The star exhales for the last time, and in an instant of profound silence, it begins to fall inward on itself. The outer layers, vast oceans of plasma that once stretched for millions of miles, now have nothing holding them up. They rush inward, a silent avalanche of matter collapsing toward the center. It is not an explosion, it is an implosion, a quiet, heavy sigh on a scale that is almost impossible to comprehend. For some stars, this collapse triggers a final, brilliant supernova, a death cry of light that illuminates its galaxy. But for the true giants, the collapse is so swift, so total, that it swallows the explosion before it can even begin. The star simply goes out. It folds in on itself, squeezing its own substance past every known limit of physics, until all of its mass, the weight of 100 suns, is compressed into a space smaller than a single atom. What this really means is that a black hole is not born from a bang, but from a hush. It is the remnant of a star that has lost its inner light, its inner strength, and has finally succumbed to its own incredible weight. It is a point of impossible density, a scar left in the fabric of space-time. It no longer shines, it no longer burns, it simply is. It is pure gravity, pure curvature. The gentle valley in space-time that the star once created has now become a puncture, a well so deep and so steep that it seems to have no bottom. The star itself is gone, replaced by this new, quiet center of immense gravity, and around this point of stillness, a boundary forms in the cosmic ocean, a perfect, dark sphere. A quiet shore from which no traveller can ever return. Around this point of stillness, a boundary forms, a perfect dark sphere suspended in the cosmic ocean. This boundary is the event horizon. We often imagine it as a physical thing, a wall, a surface, or the mouth of a monster, but its true nature is far more subtle and far more poetic. It is not a place, but a moment. It is not a barrier, but a threshold. Let's return to our image of the cosmic ocean of space-time. If the black hole is a puncture, a drain of impossible depth, then the event horizon is like the edge of a cosmic waterfall. Imagine a vast, slow-moving river, so wide and calm that far upstream, you can paddle your boat in any direction you please. You can move toward the edge, away from it, or drift alongside it. The current is gentle, a subtle pull you barely notice. This is the universe far from the black hole, but as you drift closer, you notice the water is moving a little faster. You have to paddle a bit harder to move away. The gentle slope of the river is getting steeper. As you get closer still, you reach a point where the river's current is moving at exactly the fastest speed you can possibly paddle. If you turn your boat and paddle upstream with all your might, you can just manage to stay in one place, fighting the current to a standstill. You are on the very brink. 1 inch forward, and the current will be too strong. 1 inch back, and you can still escape. This invisible, shimmering line in the water, the point of no return, is the event horizon. Now, imagine that the fastest possible speed is not the speed of your boat, but the speed of light itself. The event horizon is the precise boundary where the inward flow of space-time, the rush of the cosmic river into the black hole's depths, becomes faster than the speed of light. Light itself, the fastest thing in the universe, is like a tireless swimmer. Far from the black hole, it can travel in any direction. But at the event horizon, even light, swimming away as fast as it can, is simply carried inward by the current. It is held in place for a moment, a shimmering photon running on a cosmic treadmill, before being swept over the falls. What this really means is that the event horizon is not a wall you would crash into. It is an invisible, silent point of passage. If you were to drift across it in a spaceship, you wouldn't feel anything at all. No jolt, no sound, no sensation. The moment of crossing would be utterly unremarkable. You would look back and see the universe of stars still shining behind you. You could still receive messages from the outside, but you could never send a message back. You have crossed the threshold where all paths, every possible direction you could ever move, now lead inward. The very fabric of reality is flowing inward faster than you can move through it. There is a profound sense of inevitability here, a quiet acceptance. The event horizon is not an act of aggression, it is a consequence of geometry. It is the shore of no return, a calm, perfect sphere of darkness defined not by what it is, but by what it makes impossible. It is from this quiet, predictable shore that we get our common image of a black hole, the hungry, all-consuming predator of the cosmos. But even that idea is gentler and more misunderstood than we might think. Even that idea, the image of a hungry cosmic predator, is gentler and more misunderstood than we might think. We have this picture in our minds of a black hole as an aggressive cosmic vacuum cleaner, actively roaming the universe and sucking up everything in its path. It is a compelling image, born from science fiction and our own primal fears of the dark, but the reality is far more passive, far less threatening. In fact, from a safe distance, a black hole is a remarkably well-behaved neighbour. Let's imagine our own solar system for a moment. At its heart is the Sun, a beautiful, brilliant star, its gravity holding our Earth and all the other planets in their steady, graceful orbits. We feel its presence as warmth, as light, and as the steady anchor of our year. Now, imagine a thought experiment. If, by some impossible magic, our Sun were to be instantly replaced with a black hole of the exact same mass, what would happen to us? Our movies and the stories tell us we would be immediately pulled in, swallowed by the darkness. But the truth is, here on Earth, we wouldn't feel a thing, at least not gravitationally. The orbits of the planets would remain completely unchanged. The Earth would continue on its same familiar path, completing its year just as it always has. The only difference would be that the light and warmth would vanish, plunging us into a sudden, deep and permanent cold. The black hole, despite its terrifying reputation, exerts the exact same gravitational pull as the star it replaced. The curve it creates in space-time, out here where we are, is identical to the Sun's penhole. You have to get very, very close to a black hole to encounter the strange, extreme effects of its gravity near the event horizon. Think of it like a quiet, unassuming person sitting on a park bench. From across the park, they have no influence on you. You can walk around them, near them, or past them without any effect. It is only when you choose to walk right up to them and sit down that you enter their personal space, their sphere of direct influence. A black hole is the same. It does not suck. It does not reach out and grab things. Matter must wander into its immediate vicinity, crossing that critical threshold to be captured. Its gravitational influence, like that of any star or planet, weakens with distance. What this really means is that a black hole is not a monster. It is simply a point of extreme density, with a very small, very well-defined zone of danger around it. It is a predictable and stable celestial object. It follows the same rules of gravity as everything else in the cosmos. In fact, most galaxies, including our own Milky Way, have a supermassive black hole sitting peacefully at their center, acting as the quiet gravitational anchor around which everything else elegantly spins. It is not a predator destroying the galaxy. It is the silent, heavy heart that gives it structure. This stability, this predictability, is the normal state of affairs. Our universe is not a chaotic mess of cosmic monsters. It is a place of immense, slow and graceful dances, all governed by the gentle curvature of space-time. It is a galaxy full of stable families of stars, all moving together in a predictable cosmic waltz. But it is in the disruption of this quiet dance that our story truly begins. This stability, this quiet dance, is the natural state of the cosmos. Imagine our Milky Way galaxy, not as a static jewel disk, but as a vast, slowly turning carousel of light. It is a city of 100 billion stars, each one a tiny glowing speck, all moving in concert. This city has structure, it has neighborhoods, and it has a calm, predictable rhythm. The stars in the spiral arms, like our own sun, move in wide, circular paths around the galactic center, a journey that takes hundreds of millions of years to complete. They are like boats on a vast, cosmic river, all flowing in the same general direction. In the center of this city, shrouded by veils of gas and dust, lies Sagittarius A, our galaxy's supermassive black hole. It is the quiet, heavy anchor of the entire system. It is not a tyrant, but a silent fulcrum, the point of gravitational balance around which the entire galactic waltz is choreographed. The stars closest to it move with incredible speed, like dancers spinning furiously in the center of the ballroom, while those farther out, like us, drift in slower, more leisurely arcs. This entire structure is held together in a delicate equilibrium. The combined gravity of all the stars, the gas, the dust, and the unseen dark matter creates a vast, shallow gravitational well, the galaxy itself. Each star is held within this well, tethered to the collective, unable to simply wander off into the intergalactic void. It is a cosmic family, a community bound by mutual gravity. Think of it as a beautiful, intricate celestial dance that has been unfolding in an unbroken rhythm for billions of years. Stars are born in glowing nebulae, live out their quiet lives, and die, sometimes creating new black holes, which then seamlessly join the dance. Everything has its place. Everything has its orbit. Even the smaller, stellar mass black holes, the remnants of ancient, giant stars, are part of this dance. They orbit the galactic center, just like any other star. They are quiet, dark partners in the waltz, their presence felt only by the slight gravitational tug they exert on their neighbors. They are predictable, they are stable, they are home. What this really means is that the universe on a grand scale strives for a state of calm. The galaxy is a self-contained system, a cosmic ecosystem where every member has a role and a path. For an object to be ejected from this system, for a star or a black hole to be thrown out of this dance, it requires a significant disruption. The calm has to be broken. The gentle, predictable rhythm of the waltz must be interrupted by a sudden, chaotic and powerful new movement. It is this rare, violent interruption that can turn a stable, orbiting black hole into a lonely exile. It is an event that takes 3 dancers, pulling them into a spin so complex and so powerful that one of them is flung away, sent soaring out of the ballroom and into the lonely night. That quiet, stable dance can be broken. The gentle rhythm of the cosmos can be shattered by a sudden, chaotic encounter. This is where our wanderer is born. It begins not with 1 dancer, or even 2, but with 3. Imagine a particularly dense and ancient part of the galaxy, a star cluster, where thousands of stars are packed together in a glittering gravitational ballroom. Here, the dance is much more intimate, the orbits tighter and more complex. Now, picture 3 black holes in this cluster, all born from long-dead giant stars. For a time, They may orbit each other in a stable, predictable pattern, a beautiful and complex triple, pirouette. But their dance is not destined to last. Gravity is a patient and relentless choreographer. Slowly, inexorably, it pulls them closer. Their orbits begin to warp and decay, spiraling inward. The dance becomes faster, more frantic, more chaotic. They swing past each other in tight, slingshotting arcs, exchanging energy and momentum in a dizzying gravitational embrace. Think of it like three ice skaters spinning together, holding hands. As they pull closer, their spin accelerates wildly. The energy in the system skyrockets. It becomes unstable, a frenzy of motion. The system must find a way to release this energy, to settle back into a state of calm, and it does so in a single, dramatic act. Two of the skaters, in their chaotic spin, might link arms and, in a final powerful whip-like motion, hurl the third skater away from them with incredible force. This is precisely what happens in the dance of the three black holes. The system violently ejects one of its members. In a final close pass, two of the black holes form a tight, stable binary pair, settling into a new, calmer dance together. All the excess energy and momentum of the chaotic interaction is transferred to the third black hole. It is given a tremendous gravitational kick, an impossibly powerful shove. This kick can be so immense that it accelerates the black hole to a speed far beyond the escape velocity of the galaxy itself. It is no longer bound by the collective gravity of its home. The gentle tether that held it in the galactic family is snapped. It is now moving so fast that it will soar right out of the galactic disk, leaving its two former partners behind. It has been thrown from the ballroom. This is the moment a rogue is born. What this really means is that our wanderer is an exile, not a conqueror. It did not choose to leave. It was ejected by a chaotic family dispute. The process is a beautiful, if violent, demonstration of conservation of energy. To achieve a state of greater, the stability, the three-body system cast out one of its own. The remaining binary pair is now the calm after the storm, while the ejected third member becomes a silent testament to the brief moment of chaos. It is a bullet fired from a gravitational gun, a ghost shot into the empty darkness between the galaxies, and so its long and lonely journey begins. There is no fanfare, no explosion to mark its departure, just a silent, sudden acceleration and the beginning of a path that leads away from all the light it has ever known, and so its long, lonely journey begins. There is no sound to mark its departure, no flash of light against the velvet blackness. An ejection like this is an event of profound silence. One moment, the black hole is part of a frantic gravitational dance deep within a star cluster, surrounded by the shimmering haze of 1 billion distant suns. The next, it is moving with unimaginable speed on a trajectory that leads out and away from everything. Imagine the view from just behind this departing ghost. The familiar tapestry of the galaxy, the glowing river of the Milky Way that has been its home for eons, begins to recede. At first, the change is subtle. The star cluster it just left shrinks to a faint, glittering jewel. Then, the dense spiral arms, with their vibrant pink nurseries of newborn stars and their dark lanes of cosmic dust, begin to lose their detail. The entire galaxy, that vast city of light, starts to contract, pulling together into a single cohesive shape. The black hole itself feels nothing. It is a point of pure mass, a perfect sphere of inescapable gravity. It has no senses, no awareness. It is simply an object in motion, obeying the laws of physics with perfect fidelity. It carries with it the memory of the immense gravitational kick it received, a memory encoded in its velocity. It is now a traveller, an unwitting pilgrim on the longest journey imaginable. It climbs up and out of the galaxy's shallow gravitational well, like a stone thrown with impossible force from the bottom of a valley, soaring over the ridge and into the unknown lands beyond. As it travels, the light from its home galaxy shifts. The Doppler effect, the same phenomenon that changes the pitch of a passing siren, begins to stretch the light waves of the receding stars. Their brilliant whites and blues are pulled toward the red end of the spectrum, a process called redshift. The galaxy behind it begins to look dimmer, older, and redder. It is a final, fading ember in the rearview mirror of its journey. Eventually, after thousands, perhaps millions of years of travel, it crosses the galactic halo, the vast, sparse sphere of old stars and dark matter that surrounds the main disk. It is now truly in the void. The great spiral of the Milky Way is just one of many smudges of light in the sky, a beautiful, distant island universe that is no longer home. The darkness between the galaxies is a different kind of darkness, deeper, emptier, and colder than any it has known before. What this really means is that the exile is now complete. The black hole has become a solitary entity, untethered from any larger structure. It is an object defined not by what it belongs to, but by its own self-contained gravity. It is a ghost in the machine of the cosmos, a piece of a galaxy that has come loose and is now adrift on the grandest of all oceans. It is a silent warp in the fabric of reality, a moving depression in space-time gliding invisibly through the great and silent dark. It is now a silent warp in the fabric of reality, a moving depression in space-time gliding invisibly through the great and silent dark. As it travels, it is not simply a rock flying through emptiness. It is a fundamental disturbance in the very medium of the universe. It is a knot of space-time, a concentrated pucker in the cosmic fabric, moving with purpose and momentum through the intergalactic void. Let's return to our vision of space-time as a vast, calm ocean. Most of this ocean, the deep void between galaxies, is almost perfectly flat. It is a placid, featureless expanse, stretching for millions of light-years in every direction. But our rogue black hole is a moving anomaly in this serene flatness. Imagine a single, heavy marble rolling silently across an enormous, taut, dark sheet. You cannot see the marble itself, but you can see the effect it has on the sheet. As it moves, a deep, conical depression travels with it. The fabric in front of it dips down, and the fabric behind it rises back up. The marble is inseparable from the dent it creates. Our rogue black hole is just like this, but in 3 dimensions. It is a spherical well of gravity, a deep, invisible vortex, travelling through the substance of space-time. The very geometry of the universe is warped in its immediate vicinity. Straight lines are no longer straight. The flow of time itself is subtly altered. It carries its own pocket of distorted reality with it on its journey. This moving dent is its essence. It is not just an object in space. It is a profound shape of space. Think of the stillness of this journey. The black hole is moving at hundreds, perhaps thousands of kilometers per second, a speed that is almost impossible for us to imagine. Yet, from its own perspective, there is no sensation of motion. There is no cosmic wind, no friction, no sound. It is a state of perfect, silent coasting. It is adrift in an environment of such profound emptiness that it might travel for 1,000,000 years without encountering a single speck of dust. Its passage is utterly serene. Yet, this serene passage has consequences. The moving curve in space-time affects everything it passes, even from a great distance. Any stray particle of intergalactic dust, any lonely hydrogen atom that drifts too close to its path, will be subtly deflected, its trajectory altered by the passing gravitational well. It is like a silent, invisible ship passing in the deep ocean. It creates no sound and shows no lights, but its passage generates a deep, slow wake in the water, a subtle disturbance that spreads outward long after it has gone. What this really means is that even though the black hole is invisible, its journey is not entirely without a trace. It is writing its story in the geometry of the cosmos. It leaves behind a trail of subtle gravitational disturbances, a memory of its path etched into the fabric of space-time itself. It is a ghost whose presence can only be inferred by the way it makes the world around it bend. And it is this bending, this warping of the universe, that gives us our very first clue on how we might one day catch a glimpse of this unseen traveller. We may not be able to see the wonder itself, but we can see the way it bends the light of the things behind it. We may not be able to see the wonder itself, but we can see the way it bends the light of things far behind it. This is our first glimmer of evidence, a way to witness the presence of a ghost. The phenomenon is called gravitational lensing, and it is one of the most beautiful and subtle predictions of Einstein's theory of relativity. It transforms the rogue black hole from a mere object into a cosmic lens, a piece of curved space-time that can magnify, distort, and reshape the light of distant stars and galaxies. Imagine you are looking at a single distant candle flame in a completely dark room. Now, imagine someone silently passes a heavy, perfectly clear glass sphere between you and the candle. You can't see the glass sphere itself, but you would see its effect on the candle's light. The flame might suddenly appear brighter, magnified. It might split into two or more identical images, or even be smeared into a shimmering, perfect ring of light if the alignment is just right. The glass sphere, by bending the path of the light rays, has revealed its presence. Our rogue black hole does precisely the same thing, but its lens is not made of glass. Its lens is made of pure, curved space-time. As it drifts through the void, it might, by pure chance, pass almost directly in front of a distant, unrelated star. From our perspective here on Earth, billions of years later, we are watching that distant star, a tiny, steady pinprick of light. Then, as the invisible black hole drifts into the line of sight, something magical happens. The light from the distant star, which should be blocked by the black hole, instead gets bent around it. The deep gravitational well of the rogue acts like a lens, gathering up the starlight and refocusing it in our direction. For a brief period, perhaps a few days or a few weeks, the distant star will appear to get brighter, its light amplified by the unseen object. Then, as the rogue continues on its silent path, the star will fade back to its normal brightness. This fleeting, symmetrical brightening and dimming is called a microlensing event. It is a telltale signature, a whisper in the light that says, something dark and heavy just passed by. On very rare occasions, if the alignment between us, the black hole, and the background star is absolutely perfect, the effect is even more spectacular. The starlight is not just brightened, but smeared into a perfect, delicate circle of light around the black hole's position. This is called an Einstein ring. It is a ghostly halo, a celestial smoke ring, with the invisible rogue sitting right in its center. To see one of these would be to see the shape of gravity itself, a perfect circle drawn in the sky by a phantom hand. What this really means is that we have a way of seeing the unseen. We can hunt for these cosmic ghosts not by looking for darkness, but by watching for strange and beautiful tricks of light. Astronomers today do just this, using telescopes to monitor millions of stars at once, watching patiently for one of them to brighten and fade in just the right way. Each detection is a fleeting glimpse into the invisible, a universe, a confirmation that these silent, lonely wanderers are truly out there, charting their course through the dark. But lensing is not the only way a rogue might betray its presence. Sometimes, even in the deepest dark, the ghost might light a tiny candle of its own. Sometimes, even in the deepest dark, the ghost might light a tiny candle of its own. While the intergalactic void is profoundly empty by any human standard, it is not a perfect vacuum. There are thin, wispy tendrils of gas, mostly hydrogen, that stretch between the galaxies like the strands of a vast cosmic web. These clouds are incredibly diffuse, with only a few atoms per cubic meter, 1 billion times less dense than the best vacuum we can create on Earth. To a star or a planet, passing through such a cloud would be completely unnoticeable, but to a black hole, it is a potential meal, however faint. As our rogue wanderer glides silently through one of these immense cold clouds of interstellar gas, its powerful gravity begins to draw the sparse material inward. The hydrogen atoms, which have been drifting aimlessly for billions of years, begin to feel a gentle, inexorable pull. They are drawn out of their slow cosmic drift and begin to fall toward the invisible center of gravity. They don't fall straight in. Instead, because of their own tiny random motions, they spiral inward, like water draining from a vast, shallow basin. As more and more atoms are captured, they begin to collide. This swirling collection of gas forms a faint, ghostly disk around the black hole, known as an accretion disk. It is a cosmic whirlpool of captured material, all spiraling toward the event horizon. And as the atoms in this disk jostle against each other, the friction generates heat. The gas, which was once colder than deep space, is heated to thousands, even millions of degrees. And anything that hot begins to glow. Imagine our rogue, a perfect sphere of absolute blackness, now surrounded by a dim, ethereal halo of light. It is not the brilliant, ferocious glare of an accretion disk around a supermassive black hole in a galactic core. This is a much quieter, gentler affair. It is a soft, lonely glow in the middle of nowhere, a cosmic lantern fueled by the thinnest of mists. The light it emits might be mostly in the form of X-rays or ultraviolet light, invisible to our eyes, but detectable by our telescopes. It would be a tiny, isolated point of high-energy light in a region of space that should be completely dark and quiet. What this really means is that the black hole, in feeding, betrays its own position. It's like seeing the faint breath of a person on a cold winter's night. You can't see the person in the dark, but the cloud of vapor they exhale reveals where they are. This faint glow is the black hole's breath, a whisper of radiation that tells us not only that it is there, but that it is interacting with its environment. This lonely feast is a slow, patient process, perhaps taking millions of years to consume even a small part of the cloud. The accretion disk might flicker and change in brightness over time as it encounters thicker and thinner patches of gas. Finding such a glow would be like finding a single faint candle burning in the middle of an empty desert at night. It would be a beacon of activity in a place of profound stillness. This tiny glowing halo is a second way we might find these cosmic ghosts. The first was seeing how they bend the light of others. This is seeing the light they make for themselves. And this light reveals that the Wanderer is not just a passive object, but a dynamic one, an engine that can transform the cold, dark matter of the void into heat and light, and in doing so, perhaps even become an accidental architect of new creation. This faint glow reveals that the Wanderer is not just a passive object, but a dynamic engine, capable of transforming its environment in unexpected ways. It is not just a destroyer, but perhaps, in the strangest of ironies, an accidental creator. To see this, let us imagine our rogue's path takes it not through the thin intergalactic mists, but back into a galaxy, not its home, but another, unfamiliar island of stars. And by chance, its trajectory leads it toward a vast, beautiful stellar nursery. Picture this place. It is a nebula, an immense cloud of molecular hydrogen and cosmic dust, spanning light years across. It is a place of breathtaking beauty, a celestial watercolor painting of deep reds, vibrant pinks, and soft blues. These colors come from the young, hot stars already being born within it, their ultraviolet light causing the gas to fluoresce like a cosmic neon sign. But most of the cloud is cold, dark, and still. It is a reservoir of raw material, patiently waiting for a trigger to begin the process of star formation. For a new star to be born, a region of this gas must be compressed, squeezed together by some external force until its own gravity can take over and pull it into a new, shining sphere. Usually, this trigger is a shock wave from a nearby supernova, or the gravitational stirring of the galaxy's spiral arms. But now, into this serene and fertile landscape, comes our silent, invisible wanderer. The rogue black hole plunges into the nebula. It is not a violent collision. The cloud is so diffuse that the black hole passes through it like a ghost through a fog. It consumes a tiny wisp of the gas, creating that faint accretion disk we spoke of. But its most profound effect is not what it eats, but what it stirs. As the black hole, with its immense concentrated gravity, moves through the cloud, it carves a path. It is a gravitational plough, a moving well of space-time that creates a wake in the gas behind it. In this wake, the placid, evenly distributed hydrogen is compressed. It is gathered together, pushed into dense knots and filaments. The black hole's passage provides the exact trigger the cloud has been waiting for. These newly dense regions of gas now have enough mass and are compact enough that their own gravity suddenly becomes dominant. They begin to collapse, pulling in more and more material from their surroundings. Deep within these compressed knots, the pressure and temperature begin to skyrocket, and then, one by one, like a string of celestial lamps being lit in the dark, they ignite. Nuclear fusion begins. A chain of new stars is born, tracing the exact path the invisible rogue black hole took through the nebula. What this really means is that our lonely exile has become a cosmic Johnny Appleseed. It has planted a row of new suns in its wake, purely by accident. It is an agent of creation born from an act of gravitational chaos. It is a beautiful, quiet paradox, a point of absolute darkness and destruction that can trigger a line of brilliant new light. Long after the rogue has passed and is once again lost in the darkness, that straight line of young, bright blue stars will remain, a strange and beautiful scar in the nebula. Future astronomers in that galaxy might look upon this bizarrely straight stellar association and wonder what could have possibly created it, never knowing it was the fleeting passage of an unseen, wandering ghost. And its influence isn't limited to just birthing stars. Even a much more distant encounter can have gentle, long-lasting consequences for a solar system just like ours. Its influence isn't limited to just birthing stars. Even a distant, fleeting encounter can have gentle, long-lasting consequences for an entire solar system, much like our own. Let us imagine our rogue wanderer, after eons of travel, passing through the lonely outer suburbs of a star system. It does not come close to the inner planets. It does not threaten the world where life might be blooming. It passes millions, or even billions, of miles away from the system's central star. From the perspective of any inner planet, the flyby would be completely invisible, completely undetectable, a ghost in the far, deep night. But the outer reaches of a mature solar system are not empty. They are home to a vast, spherical swarm of icy bodies, a scattered shell of comets known as the Oort cloud. Think of it as a celestial orchard of frozen, sleeping snowballs, orbiting the parent star at such an enormous distance that their dance is slow, placid, and undisturbed. They are the pristine, leftover building blocks from the system's formation, drifting in a state of near-perfect hibernation for billions of years. The gravitational pull from their own sun is incredibly faint out here, a barely there whisper that is just enough to keep them tethered to the family. Now, into this quiet, stable orchard passes our rogue black hole. Its powerful gravity, even from a great distance, is a significant event. It is like a second, temporary sun suddenly gliding through the outskirts of the system. This passing gravitational wave washes through the Oort cloud, gently but inexorably disturbing the delicate orbits of these sleeping comets. It is not a violent disruption, but a subtle nudge, a gravitational tide that lifts and shifts these ancient icy bodies. Some comets are nudged into higher, more distant orbits. Others are thrown out of the system entirely, becoming lonely wanderers themselves, but a select few are perturbed in just the right way. Their slow, circular paths are changed into long, elliptical ones, their orbits now plunging them down into the inner solar system, toward the very star they have always orbited from afar. The black hole's passing has nudged them off their stable shelves and sent them on a long, slow fall. The rogue itself continues on its journey, oblivious. It has passed by in a cosmic moment. But the consequences of its passage will unfold over thousands, even millions of years. Long after the black hole is light years away, those disturbed comets will begin to arrive in the inner solar system. One by one, they fall toward the sun, their ice sublimating into gas, growing long, beautiful tails that stretch across the sky. The passing of the rogue has triggered a great and long-lasting comet shower. What this really means is that the Wanderer's influence can be a delayed and beautiful echo. It writes its story not in fire, but in ice. For any civilization living in that solar system, the sudden appearance of countless new comets in their skies would be a profound mystery, a beautiful and perhaps ominous change in the heavens. They would see it as a golden age for stargazers, never knowing that the cause was a single, dark, invisible object that passed silently through their celestial backyard 1,000,000 years before. The rogue's legacy is a slow, graceful rain of icy visitors from the dark, a reminder that even the most fleeting cosmic encounters can have consequences that ripple through time. And sometimes, the encounter is not so distant, and the consequence is not a shower of ice, but the capture of an entire world. Sometimes, the encounter is not so distant, and the consequence is not a gentle shower of ice, but the quiet capture of an entire world. Imagine a solar system, much like any other, with planets orbiting a warm, life-giving star. Now, our rogue black hole does not pass at a safe distance. Its trajectory takes it right through the heart of this system, a thread of immense gravity weaving between the orbits of the planets. The encounter is still silent, still swift, but its effects are profound and permanent. As the rogue passes, the beautiful clockwork stability of the solar system is thrown into chaos. Planets are pulled into new, eccentric orbits. Some might even be ejected from the system entirely, cast out into the interstellar dark. But for one planet, something else happens. Imagine a world, perhaps a gas giant like Jupiter, or a frozen ice world like Neptune orbiting in the outer regions of its system. As the black hole passes, this planet is gravitationally captured. It is pulled from the gentle embrace of its parent star and becomes bound to a new, dark master. The transaction is swift and silent. The planet's orbit is so radically altered that it no longer circles its sunday. It is now in a stable, permanent orbit around the rogue black hole. It has been adopted. It has become a cosmic orphan, forever tethered to this wandering point of darkness. The light and warmth of its home star rapidly recede as the black hole carries its new companion away on its endless journey into the intergalactic void. What would life be like for this captured world? It is now a planet in a solar system of one, orbiting a sun that gives no light and no heat. The sky, once filled with a familiar sun and constellations, is now a panorama of utter, unchanging blackness, punctuated only by the faint, distant smudges of faraway galaxies. The only light it might ever see again would be the faint, ghostly shimmer of its parent galaxy, shrinking to a tiny jewel in the eternal night. Yet, this orphan planet is not necessarily a dead world. A large planet, especially a gas giant, can generate a significant amount of its own internal heat, left over from its violent formation and from the slow decay of radioactive elements in its core. It could be a world of swirling dark clouds warmed from within, its surface perpetually dark but not frozen solid. If this planet had large moons, as Jupiter does, they too would be carried along. The immense gravity of the gas giant could knead the interiors of these moons, creating tidal forces that generate enough heat for liquid water to exist under their icy shells. There's something quietly poetic about this idea. An entire ecosystem, a potential cradle for life, could exist in the pitch-black darkness, orbiting an invisible ghost, warmed by the internal mechanics of its own tiny system, drifting in the absolute middle of nowhere. It is a self-contained world, a ship on an endless voyage, carrying its own life support system. What this really means is that a rogue black hole can become the anchor for a new dark kind of solar system. It is a system built not around light and fusion, but around gravity and darkness. This cosmic orphan and its family of moons would be one of the loneliest objects in the universe, a testament to a fleeting, ancient encounter. The rogue is no longer just a wanderer. It is now the heart of a bizarre and lonely family, a dark shepherd for a stolen flock, and some of these shepherds are moving at speeds that seem to defy all intuition. The rogue is no longer just a wanderer. It is now the heart of a bizarre and lonely family, a dark shepherd for a stolen flock, and some of these shepherds are moving at speeds that seem to defy all intuition. The gravitational slingshot that creates a rogue black hole can sometimes be extraordinarily powerful. In the most extreme cases, involving interactions with supermassive black holes at the galactic core, a smaller black hole can be ejected with a velocity that is a significant fraction of the speed of light itself. These are the hypervelocity exiles. They are not just drifting out of their galaxy, they are shot out, like cannonballs of pure gravity, moving at 10, 20, perhaps even 30% of the speed of light. It is a speed so immense that it is difficult to wrap our minds around it. At such velocities, it would cross the entire span of our galaxy in just a few 100,000 years, a mere cosmic eye blink. It would travel the vast empty gulf between galaxies in a handful of million years. It is a true phantom, here one moment and gone the next. But we must be careful with our language. When we think of speed, we imagine roaring engines, violent acceleration, and a rushing sense of motion. For the hypervelocity Rogue, there is none of this. Once the initial violent kick is over, its journey is one of perfect, profound stillness. According to Einstein's theory of relativity, motion is relative. From the black hole's own frame of reference, it is completely at rest. It is the rest of the universe, the galaxies and stars and cosmic dust, that is flying past it in a silent, coordinated stream. There is no cosmic wind, no sense of rushing through the void. It is a perfect inertial glide. The black hole is a silent observer in its own private, moving bubble of space-time. This is the great paradox of high-velocity travel in the cosmos. The faster you move relative to everything else, the more still and isolated your own experience becomes. It is a state of serene detachment, a testament to the immense and quiet power of the forces that set it on its path. There's a subtle change in its perception of time as well. As an object approaches the speed of light, time for that object slows down relative to a stationary observer. For our hypervelocity Rogue, the clocks would be ticking just a little bit slower. For every 100 years that pass in the universe it is leaving behind, perhaps only 99 might pass in its immediate vicinity. It is a tiny, almost imperceptible effect at these speeds, but it is there. The black hole is aging just a fraction more slowly than the cosmos through which it travels. It carries with it its own slightly younger slice of time. What this really means is that these hypervelocity rogues are not just travelers in space, they are travelers in space-time in a much more profound sense. They are cosmic bullets, yes, but they experience their journey as a state of deep meditation. They are the ultimate expression of the initial chaos that created them, now transformed into a pure, straight line of unwavering motion. They are the loneliest of all the wanderers, for they are leaving the clustered galaxies of the universe behind so quickly that they are destined for a future of almost perfect, absolute emptiness. And as they travel, they are constantly stirring the very fabric of the universe, creating a faint, persistent hum that is the memory of their own incredible motion. As these wanderers travel, they are constantly stirring the very fabric of the universe, creating a faint, persistent hum that is the memory of their motion. This hum is not sound in any traditional sense. It is a chorus of gravitational waves, the faintest and most subtle ripples in the ocean of space-time itself. These waves are another of Einstein's beautiful predictions, a core part of his vision of a dynamic, responsive cosmos. Let's return to our image of space-time as a vast, calm body of water. Any massive object that moves or accelerates, a star, a planet, or our rogue black hole, creates tiny ripples that spread outward. Think of a perfectly smooth pond. If you were to drag your hand through it, you would create a wake, a series of small waves that travel away from the path of your motion. Gravitational waves are the cosmic equivalent of this. They are propagating disturbances in the geometry of reality, stretching and squeezing the fabric of space-time as they pass. These waves are incredibly, almost impossibly faint. When a gravitational wave from a distant cosmic event passes through you, it stretches and compresses your body, and the very room you are in, by an amount smaller than the width of an atomic nucleus. The effect is so minuscule that for a century it was thought to be undetectable. But we have now built instruments, vast L-shaped laser interferometers, so sensitive that they can feel this subtle cosmic breathing. Our rogue black hole, as it glides through the intergalactic void, is a source of these waves. Simply by being a massive object in motion, it is constantly radiating a faint hum of gravitational energy. This hum is the quietest of all whispers, a byproduct of its very existence. It is the signature of its journey, a story being written into the fundamental structure of the cosmos. The waves travel outward from the rogue in all directions at the speed of light, carrying with them information about the black hole's mass, its speed, and the direction of its travel. There's something deeply profound in this. The black hole is utterly silent and invisible, yet its passage is not without a voice. Its voice is just spoken in a language our ears cannot hear, a language of pure geometry. It is a song sung into the fabric of reality itself. We cannot yet detect the gravitational waves from a single, smoothly moving rogue black hole. They are far too faint for our current technology, but we can imagine a future where our instruments are sensitive enough to listen to this background hum of the universe. In such a future, we might be able to map the paths of these invisible wanderers by listening for their faint individual gravitational signatures. It would be like tracking the movements of silent ships in a dark ocean by listening for the subtle sound of their passage through the water. Each rogue would have its own unique note in the cosmic symphony. What this really means is that the universe is filled with a constant, incredibly quiet chorus of these gravitational whispers. The journey of every rogue black hole, every orbiting star, every spiraling galaxy contributes to this background hum. It is the sound of the cosmos in motion, the collective memory of every gravitational event that has ever happened. The rogue's journey is not just a path through space, but a thread in this immense, invisible tapestry of ripples. And among these threads, there might be some that are far, far older and more mysterious than others, wanderers that have been adrift not for millions, but for billions of years, since the very dawn of time itself. Among these threads, there might be some that are far older and more mysterious than others, wanderers that have been adrift not for millions of years, but for billions, since the very dawn of time itself. These are not the ghosts of dead stars. They are something else entirely, something far more ancient and speculative. These are the primordial black holes, the oldest wanderers of all. To imagine their origin, we must cast our minds back to the very first moments of the universe. Not just to the time of the first stars and galaxies, but much, much earlier. Go back to the first second after the Big Bang. The entire observable universe was a hot, turbulent, and unimaginably dense sea of energy and exotic particles. It was a place of extreme violence and fluctuation, expanding at a furious rate. In this chaotic primordial soup, it is theorized that some regions, just by pure chance, could have become so incredibly dense that they spontaneously collapsed under their own gravity, directly into black holes. These would not be formed from the collapse of a star. There were no stars yet. They would be formed directly from the raw, compressed energy of the newborn universe itself. These are the primordial black holes. Unlike their stellar mass cousins, which are all quite large, these ancient wanderers could have formed with a vast range of masses. Some could have been as heavy as mountains, others as small as a single atom, all compressed into an infinitesimal point. The smallest of them would have been so tiny that they would have evaporated long ago through a process called Hawking radiation. But those that were formed with the mass of an asteroid or larger could still be with us today, silent relics from the universe's first breath. If they exist, they have been wandering the cosmos ever since. They are the original rogues, born into exile. They never belonged to a galaxy, never orbited a star. Their journey began before any of these structures had even formed. They have been silent witnesses to the entire history of cosmic evolution. They watched the first stars ignite, saw the first galaxies coalesce, and have been drifting through the ever-expanding darkness for nearly 14 billion years. There is a deep sense of antiquity to these objects. They would be made of a kind of matter energy that hasn't existed since the first moments of creation. They carry with them, locked behind their event horizons, the physical conditions of the Big Bang itself. They are time capsules from a universe that is completely alien to us, a universe without structure, without light, without form. What this really means is that our story of the rogue black hole might have two different protagonists. There is the stellar rogue, the ghost of a dead star, cast out from its family. And then there is the primordial rogue, an ancient elemental being that has never had a family at all. It is a lonely god, born in the fire of creation, destined to an eternity of silent travel. Finding one of these would be more than just finding a wandering object. It would be like finding a fossil from the first second of time. It would be a direct physical link to the very beginning of everything. And if these tiny ancient ghosts are numerous enough, they might even help us solve one of the biggest mysteries in the cosmos. But the idea of exile isn't just limited to these small ancient wanderers. Sometimes, the chaos of the universe can eject something far, far larger. The idea of cosmic exile isn't limited to these small ancient wanderers. Sometimes, the chaos of the universe can be so immense that it ejects something far, far larger. It can unmoor the very heart of a galaxy. We now know that at the center of nearly every large galaxy, including our own, there sits a supermassive black hole, a true behemoth millions or even billions of times the mass of our Sunday. These are not the remnants of a single star. They are cosmic monsters that have grown over eons by consuming vast clouds of gas and merging with countless stars and smaller black holes. These giants are the gravitational anchors of their galaxies. They are the calm, heavy center around which everything else revolves. The entire galactic dance is choreographed around their immense presence. They are the definition of stability, the very essence of a home's foundation. The idea of one of them being cast out seems impossible, like a mountain being thrown into the sky. Yet, under the right cataclysmic circumstances, it can happen. The process begins with a galactic merger. Imagine two large spiral galaxies, each with its own supermassive black hole at its core, being drawn together by their mutual gravity. Over millions of years they dance around each other, their spiral arms distorted into long, beautiful tidal tails. Eventually, they collide and begin to merge, their stars and gas clouds mingling in a chaotic, swirling frenzy of star formation. Deep in the heart of this chaotic merger, the two supermassive black holes begin a dance of their own. They sink toward the new center of the combined galaxy, shedding energy as they stir up the stars around them. They begin to orbit each other, a binary pair of gravitational titans, spiraling closer and closer. As they do, they begin to radiate a stupendous amount of energy in the form of gravitational waves. These ripples in space-time are no longer a faint hum. They are a deafening roar, a storm that carries away an unbelievable amount of energy. In the final moments of their merger, if the two black holes are not perfectly equal in mass or spin, these gravitational waves can be emitted asymmetrically. More energy is blasted out in one direction than another. And because of the law of conservation of momentum for every action, there is an equal and opposite reaction. This asymmetric blast of gravitational waves acts like a colossal rocket engine. The newly merged, even larger, supermassive black hole receives a kick in the opposite direction. This kick can be so mind-bogglingly powerful that it can eject the new supermassive black hole from the galaxy it just helped to create. Imagine that. The gravitational anchor of an entire galaxy, the very heart of this new, larger stellar city, is suddenly sent hurtling into intergalactic space at thousands of kilometers per second. What this really means is that a galaxy can be left without its heart. It is a profound and unsettling idea. The new galaxy would eventually settle down, its stars finding new, stable orbits. But it would be a galaxy with an empty center, a kingdom without a monarch. And out in the deep void, a true monster is on the move. A single object with the mass of 1 billion suns, a wanderer of unimaginable scale, is now gliding silently through the darkness. Its passage would be a cataclysm for anything that strays into its path. And more astonishing still, it might not be travelling alone. This ejected monarch, this supermassive wanderer, might not be travelling alone. In the moments before its violent exile, it was sitting at the densest, most crowded part of its galaxy. The region around a supermassive black hole is a swarming, glittering nest of stars, all held in tight, fast orbits by its immense gravity. This is the galactic nucleus, a place of extreme stellar density. When the supermassive black hole is ejected, its gravity is so overwhelming that it can carry its closest and most tightly bound attendants with it. It doesn't just get kicked out of the party, it takes the entire dance floor with it. A dense cluster of its most loyal, starry subjects are ripped from their home galaxy and dragged along into the intergalactic void. They are a royal court in exile, following their dark, invisible monarch on an endless journey. Astronomers call this bizarre object a hypercompact stellar system. Imagine it. Out in the middle of the deep, empty darkness between galaxies, where there should be nothing but the faintest wisps of gas, there is a tiny, impossibly bright ball of stars. It would look like a single brilliant star to the naked eye, but through a powerful telescope, it would resolve into a shimmering jewel-like cluster of thousands, maybe even millions of suns, all packed into a space only a few light years across. It is a miniature galaxy, a fugitive city of light, torn from its much larger home. At its center, completely invisible, is the supermassive black hole that is the reason for its existence. The stars in this tiny, dense system would be whipping around their dark master at incredible speeds, their orbits chaotic and frenzied. It would be a place of stunning beauty and intense gravitational violence. The night sky on a planet within this system would be an unbelievable sight, a ceiling of blazing, overlapping suns, a perpetual, dazzling twilight. There would be no true darkness, only the blinding light of 1,000 close neighbors. What this really means is that a rogue supermassive black hole can create a new kind of celestial object, a ghost galaxy. It is a piece of a galactic core, adrift on the cosmic ocean. It is a self-contained ecosystem of stars, forever bound to a master they followed into exile. Finding one of these would be an extraordinary discovery. It would be a smoking gun, definitive proof that these cataclysmic ejections of galactic hearts truly happen. We would be looking at the wreckage of a galactic merger, a piece of cosmic shrapnel from one of the most violent events the universe can produce. This ghost galaxy would be on a one-way trip to nowhere. It is too small and too fast to be captured by another galaxy. It is destined to wander the void forever, a tiny, glittering island of light in an endless sea of darkness. It is a profound and lonely image, a testament to the fact that in the cosmos, no structure, no matter how grand or seemingly permanent, is safe from the possibility of exile. And the search for these objects, whether they are a single black hole or a fugitive star cluster, is one of the greatest challenges in modern astronomy. It is a search for a shadow, a whisper, a ghost in the grandest of all dark rooms. The search for these objects, whether they are a single black hole or a fugitive star cluster, is one of the greatest challenges in modern astronomy. It is a search for a shadow in the dark, a whisper against a backdrop of near-perfect silence. How do you find something that emits no light, makes no sound, and is potentially billions of miles away floating in the empty space between galaxies? It is an observational puzzle of profound difficulty, requiring immense patience and even greater ingenuity. Imagine you are in a completely dark warehouse, the size of a city. You know, somewhere in this vast space, there is a single silent person, dressed in black, moving slowly. How would you find them? You can't see them directly. You can't hear them. Your only hope is to notice their subtle influence on their environment. Perhaps you could shine a flashlight on the far wall and watch for a fleeting shadow to pass in front of the beam. Or maybe you could cover the floor in a thin layer of fine dust and look for a single trail of footprints. Hunting for rogue black holes is a cosmic version of this exact problem. Astronomers are the detectives in this dark warehouse. The gravitational lensing events we spoke of earlier are the equivalent of watching for that fleeting shadow. By monitoring hundreds of millions of stars, night after night, we look for that one star that momentarily brightens in a specific telltale way, betraying the passage of an unseen mass. It is a search for a single anomalous needle in a haystack of cosmic proportions. The Hubble Space Telescope and other ground-based observatories are engaged in this patient, the meticulous work, slowly building a statistical map of these invisible wanderers. The search for the faint glow of an accretion disk is another method, akin to looking for the faintest puff of warm breath in that cold, dark warehouse. Astronomers use X-ray telescopes to scan the empty voids between galaxies, looking for isolated points of high-energy radiation that have no obvious source, no host galaxy. To explain them, each potential detection is a painstaking process of elimination, ruling out every other possibility before concluding that it might, just might, be the lonely feast of a wandering black hole. And as for the ghost galaxies, the hypercompact stellar systems, the search is different again. We look for tiny, unresolved smudges of light in the deep void that have the wrong color, the wrong signature. Their light would be the combined light of old, tightly packed stars, different from a distant quasar or a foreground star. Then, by measuring the motion of the light from that smudge, we can see if the stars within it are moving at impossible speeds, orbiting an unseen center of immense mass. Finding one would be like seeing that trail of footprints in the dust, a clear sign that something massive and unseen has passed by and has left a part of its story behind. What this really means is that the search for these rogues is a testament to the human spirit of exploration. We are trying to map the invisible. We are using the most subtle of clues to piece together a story that is written in darkness. It is an act of deep listening, of paying attention to the quietest whispers of the cosmos. Every candidate we find, every piece of evidence we gather, adds a new brushstroke to our emerging picture of this unseen population of cosmic travelers. And as we try to imagine what it would be like to get close to one, we are forced to confront one of the strangest aspects of their nature, the way they warp and bend the flow of time itself. As we try to imagine what it would be like to get close to one of these wanderers, we are forced to confront one of the strangest aspects of their nature, the way they warp and bend the flow of time itself. This is not science fiction. It is a fundamental consequence of gravity, a phenomenon known as time dilation. According to Einstein, gravity is the curvature of space-time, and the deeper the curve, the slower time flows. Imagine time not as a universal ticking clock, but as a river, in the flat, open plains of the intergalactic void, far from any massive object. This river flows at a steady, consistent pace. This is the baseline rhythm of the universe, but near any massive object like a star or a planet, the river of time is gently diverted, flowing just a fraction of a second slower. The effect is minuscule but measurable. The clocks on our GPS satellites, which are in a slightly weaker gravitational field than we are on the surface, actually tick a tiny bit faster. We have to constantly correct for this effect to make the system work. Now, imagine this river of time encountering the impossibly deep gravitational well of our rogue black hole. The river doesn't just dip, it plunges into a deep, swirling vortex. As you get closer and closer to the event horizon, the flow of time slows down dramatically. For an observer watching from a safe distance, a clock falling toward the black hole would appear to tick slower and slower and slower until, at the very edge of the event horizon, it would seem to freeze completely, its last moment stretched out for an eternity. Let's picture an intrepid imaginary probe sent to investigate our rogue. As it approaches, its onboard clock begins to run slower than our clock back on the ship. We would see its signal, which it sends out every second, begin to arrive less frequently every 2 seconds, then every 10, then every hour. Its light would become redder and dimmer as it fights to climb out of the steep gravitational well. From our perspective, the probe's journey toward the event horizon would seem to take an infinite amount of time. We would never actually see it cross. We would just see it frozen, a faint red ghost image, hovering at the brink forever. But from the probe's own perspective, nothing would feel different. Its clock would be ticking normally, 1 second at a time. It would cross the event horizon in a finite the amount of time and continue its journey inward. It is a profound and dizzying paradox. Both perspectives are true. Time is not absolute. It is relative to the observer and their position in a gravitational field. What this really means is that a rogue black hole is not just a wanderer in space. It is a moving pocket of distorted time. It is a zone of temporal stillness, a drifting piece of eternity. For any matter that falls into it, time, as the rest of the universe knows it, effectively stops. It is a place where the forward march of cosmic history comes to a halt. This idea of a place where time behaves so strangely leads us to an even deeper and more perplexing question. If a black hole is a place where the future, in a sense, ends, what happens to the past? What happens to the stories of all the things it consumes on its long and lonely journey? This idea of a place where time behaves so strangely leads us to an even deeper and more perplexing question. If the event horizon is a boundary where the future, in a sense, comes to an end, what happens to the past? What happens to the stories of all the things our rogue consumes on its long and lonely journey through the void? This is the heart of a gentle, mind-bending puzzle in physics known as the information paradox. In our universe, information seems to be fundamental. By information, physicists mean the unique, specific properties of any object, its mass, its spin, its chemical composition, the precise arrangement of its atoms. It is the story of that object, the blueprint that makes it what it is. A fundamental law of physics, as we understand it, is that information can never be truly destroyed. It can be scrambled, rearranged, or hidden, but the underlying blueprint should always be recoverable, at least in principle. If you burn a book, the information in the words is lost to you, but the information about the book's atoms is still there, encoded in the smoke, the ash, and the heat. But the whole seems to violate this rule. Imagine our rogue wanderer, in its travels, encounters a small, icy asteroid. The asteroid has a story. It has a specific chemical makeup, a unique crystalline structure, a particular history of craters on its surface. As it falls into the black hole, it crosses the event horizon and is lost to our universe forever. Its matter is crushed into the singularity, a point of infinite density where the laws of physics break down. After the asteroid is consumed, the black hole is changed in only 3 ways. Its mass increases a little, its spin might change a little, and its electric charge might change a little. All the other information that made the asteroid unique, its story, its intricate structure, seems to have vanished completely. It has been wiped clean, reduced to just 3 simple numbers. The universe, it seems, has forgotten how to build that asteroid. This is the paradox. On one hand, we have the law that says information cannot be destroyed. On the other, we have black holes, which appear to be perfect information shredders. For decades, physicists, including the brilliant Stephen Hawking, have wrestled with this gentle contradiction. Hawking initially believed the information was truly lost, a shocking idea that challenged the very foundations of physics. But the debate has evolved, and now many believe the story is more subtle. Perhaps the information isn't lost, but is somehow stored or encoded on the surface of the event horizon itself, like a kind of cosmic hologram. Or maybe it is slowly and imperceptibly leaked back out into the universe, over trillions of years in the faint whisper of Hawking radiation. We don't yet know the answer. The puzzle remains one of the deepest and most beautiful mysteries in theoretical physics. What this really means is that our rogue black hole is not just a physical object, but a philosophical one. It is a wanderer that challenges our most basic assumptions about reality, about memory, and about the permanence of existence. It asks us a quiet, profound question. Does the universe have a memory, or can stories truly be erased? The journey of the rogue is a journey through this very question. As it drifts, it collects these lost stories, becoming a silent, wandering archive of forgotten information, its true nature hidden just beyond the quiet shore of its horizon. And perhaps, in the far, far future, this collection of stories could become the seed for something entirely new. As it drifts, our rogue collects these lost stories, becoming a silent, wandering archive of forgotten information. And perhaps, in the far, far future, this archive could become the seed for something entirely new and unexpected. Over the course of its almost eternal journey, the black hole might transform from a mere wanderer into the gravitational heart of a new creation. It could become a cosmic Johnny Appleseed on the grandest of all scales. To see how, we must zoom out, not just in space, but in time. Imagine our rogue black hole, after being ejected from its home galaxy, travelling through the intergalactic void for billions of years. The universe around it is still expanding. The great island galaxies are flying further and further apart. The cosmos is becoming a darker, emptier, and colder place. But the rogue is patient. It continues its silent glide, its powerful gravity a constant, subtle influence on the sparse medium through which it travels. Over these immense timescales, it slowly begins to accumulate matter. It drifts through the thin, wispy filaments of the cosmic web, the vast tendrils of dark matter and hydrogen gas that connect the distant galaxies. Its gravity is a patient shepherd, gently herding these stray atoms and unseen particles. It is not a dramatic feast, but a slow, steady, almost imperceptible gathering. It is like a single tiny seed falling on a vast, barren plain, and then, over millennia, slowly drawing moisture and nutrients from the air and the thin soil around it. After perhaps 10 or 20 billion years of this slow, patient accumulation, something remarkable might begin to happen. The rogue black hole has gathered a significant halo of gas and dark matter around itself. This halo is now massive enough that its own collective gravity becomes a dominant force in this empty region of space. It has become a new center of gravity where none existed before. It is a seed that has finally sprouted. This new gravitational anchor can now begin to pull in even more material from its surroundings. It becomes a gravitational oasis in the expanding cosmic desert. The gas that falls toward it will cool, condense, and eventually begin to form stars. Not a great burst of stars like in a nebula, but a slow, gentle simmering of starbirth spread out over billions more years. A few stars at first, then a few dozen, then hundreds, all orbiting their dark, unseen core. What this really means is that a rogue black hole could be the seed from which a new dwarf galaxy is born. In the profound emptiness of the void, it has acted as a catalyst, a point of nucleation for new structure to emerge. It would be a tiny, faint, and incredibly isolated galaxy born long after the main era of galaxy formation has ended. It would be a late bloomer in the cosmic garden, a child of a lonely wanderer. There is a beautiful cyclical nature to this idea. A black hole, born from the death of a star in a brilliant galaxy, is violently exiled into the dark. It wanders for an eternity, a symbol of loss and isolation. But in its patient journey, it gathers the lost and scattered dust of the universe and becomes the anchor for a new generation of stars, a new home. The exile has become a founder. The ghost has built a house. This slow creative potential stands in stark contrast to the rare moments of spectacular destruction it can cause when its path intersects with something more substantial. This slow creative potential stands in stark contrast to the rare moments of spectacular destruction it can cause when its path intersects with something more substantial. While a rogue black hole is mostly a passive and subtle influence on the cosmos, a direct, head-on encounter with a star is an event of surreal and silent violence. It is not an explosion in the way we might imagine, with fire and shrapnel. It is something quieter, stranger, and in its own way, far more profound. It is the complete and methodical unravelling of a Sunday. Let's imagine the scene. Our rogue wanderer, on its journey, is on a direct collision course with a lone, unsuspecting star, perhaps a star like our own sun, that was itself flung out from its galaxy. As the star gets closer to the black hole, the first and most powerful effect it feels is the immense tidal force. Gravity pulls on every part of the star, but it pulls much more strongly on the side of the star closer to the black hole than it does on the far side. This difference in gravitational pull begins to stretch the star. It is a cosmic tug-of-war, with the black hole's gravity pulling on the star's near side, and the star's own gravity trying desperately to hold it together. But this is a battle the star cannot win. The stretching becomes more and more extreme. The star, once a perfect glowing sphere, is pulled into the shape of an egg, then a cigar. It is being drawn out, elongated into a vast, brilliant tendril of plasma. This process is called spaghettification. The star is literally being pulled apart, unspooled like a ball of cosmic yarn. The material of the star is stretched into a long, glowing stream, thousands, even millions of miles long. This stream of superheated gas now plunges toward the black hole, but it doesn't fall straight in. It whips around the event horizon, forming a temporary and breathtakingly brilliant accretion disk. For a brief period, perhaps a few months or years, the dark, invisible rogue is surrounded by a blazing vortex of stellar material. This disk is a last magnificent flare of light from the dying star. It is the star's funeral pyre, a swirling incandescent monument to its final moments. The friction and magnetic fields within this disk heat the gas to millions of degrees, causing it to erupt in a powerful focused blast of X-rays and ultraviolet radiation. This is a tidal disruption event, and it is one of the most luminous and violent events the universe can produce. It is a sudden, brilliant flash of light from a point in the sky that was previously dark. Eventually, the material in this bright, temporary disk is consumed by the black hole. The light fades. The brief, spectacular show is over. The star is gone, its matter and its story now part of the black hole's mass. The rogue, slightly heavier than before, continues its journey in the darkness, once again invisible, once again silent. What this really means is that a rogue black hole is an agent of the most extreme form of transformation. It can take a complex, shining star, a stable fusion reactor that has burned for billions of years, and in a cosmic instant, deconstruct it back into its fundamental plasma, consuming it in a final, beautiful ribbon-like display. It is a quiet, geometric process, a demonstration of gravity's ultimate power. And as we contemplate the universe, we must face the staggering possibility that our galaxy, and the space around it, might be teeming with these invisible agents of both creation and deconstruction. As we contemplate the universe, we must face the staggering possibility that our galaxy, and the space around it, might be teeming with these invisible agents of both creation and deconstruction. The rogue black holes we have been following are not just a rare theoretical curiosity. According to our best models of galactic evolution and stellar dynamics, there should be a vast unseen population of them. They may, in fact, dramatically outnumber the stars that we can see. Think for a moment about the history of our Milky Way galaxy. Over its 13 billion-year lifespan, it has seen the birth and death of countless generations of massive stars. Every giant star that died and formed a black hole did so within the turbulent, crowded environment of a star cluster or a dense spiral arm. And in those crowded environments, the chaotic gravitational dances that lead to ejections are not just possible, they are likely quite common. Furthermore, our galaxy has grown by consuming smaller, dwarf galaxies. Each of these mergers was a violent, chaotic event, a perfect opportunity to slingshot stars and black holes out of the newly combined system. Over cosmic history, our galaxy has likely shed a significant fraction of its black hole population into the dark halo that surrounds it, and into the even deeper void beyond. So, how many could there be? The numbers from simulations are astonishing. Some astronomers estimate that there could be as many as 100 million stellar mass rogue black holes wandering in the Milky Way's halo right now. 100 million silent, invisible ghosts, drifting through the dark, each one a remnant of a long-dead sun, each one a story of cosmic exile. It is a number so large, it is difficult to hold in the mind. It suggests that for every few thousand stars we see shining in the night sky, there may be a dark, unseen wanderer gliding between them. This changes our picture of the universe. We tend to think of the cosmos as a collection of bright, shining objects, stars, nebulae, galaxies separated by a passive, empty void. But this discovery, or rather, this strong theoretical suspicion, populates that void. It fills the darkness with a hidden, dynamic population of objects. The universe is not just what we see. The visible universe might be just the foam on the surface of a much deeper, darker, and more mysterious ocean. What this really means is that we are living in a haunted galaxy. It is haunted by the ghosts of its past, by the remnants of its most massive and short-lived suns. They are a silent majority, a dark commonwealth that we are only just beginning to learn how to detect. They are part of the galactic ecosystem, just as much as the living stars are. They are the quiet, unseen members of our cosmic family. This realization opens up another, even more speculative and profound possibility. If the universe is so full of these dark, massive and invisible objects, could they be the answer to one of the greatest riddles in all of science? Could these ancient, wandering ghosts be the very thing we've been searching for, the substance that holds our galaxy together? If the universe is so full of these dark, massive and invisible objects, could they be the answer to one of the greatest riddles in all of science? Could these ancient, wandering ghosts be the very thing we have been searching for, the substance that holds our entire galaxy together? This is where our story touches upon the profound mystery of dark matter. When astronomers look at our galaxy, and indeed at other galaxies, they see a strange discrepancy. The stars on the outer edges of the galactic disk are spinning far too fast. Based on the amount of visible matter we can see all the stars, gas and dust, the gravity should not be strong enough to hold on to these fast-moving outer stars. The galaxy should be flying apart, its outer members flung off into the void like water from a spinning wheel, but it isn't. Something is holding it all together. There is a vast, unseen source of gravity, a massive, invisible halo of some unknown substance that outweighs all the visible matter by a factor of 5 to 1. We call this substance dark matter. We don't know what it is. For decades, the leading theory has been that it is a new kind of subatomic particle, something exotic that doesn't interact with light at all, which we have yet to detect in our laboratories. But there is another, more audacious possibility. What if dark matter isn't a new particle at all? What if it's made of black holes? Specifically, what if the universe's dark matter is, in whole or in part, a vast swarming population of those primordial black holes we spoke of earlier? Those ancient wanderers, forged in the fires of the Big Bang, would have been born before the galaxies even formed. They would have been drifting through the cosmos from the very beginning, acting as the gravitational seeds around which the first galaxies began to coalesce. They would be dark, they would be massive, and they would not interact with light. They fit the description perfectly. Imagine our galaxy's vast dark halo, not as a smooth cloud of exotic particles, but as a buzzing, spherical hive of trillions upon trillions of these tiny, ancient black holes, each one perhaps only the mass of an asteroid, all silently orbiting the galactic center. Their combined gravity would be more than enough to explain the rapid rotation of our galaxy. They would be the hidden scaffolding, the invisible architecture upon which our visible galaxy is built. What this really means is that the solution to one of the deepest mysteries of the cosmos might have been hiding in plain sight, or rather, in plain darkness. The story of the rogue black hole would be elevated from a curious tale of exile to the central story of our cosmic home. We would be living inside a cloud of ghosts, our sun's gentle path through the galaxy guided by the collective gravity of a population of wanderers that are older than the galaxy itself. This is still a speculative and debated idea. There are good arguments for and against it, but it is a beautiful and compelling thought. It connects the universe's very first moments to the stable, graceful structure we see today. It populates the cosmos with ancient, silent witnesses to all of history, and it gives us a new way to visualize the path of our own modern rogue as it charts its lonely course through this unseen, ghostly landscape. This idea gives us a new way to visualize the path of our own modern rogue as it charts its lonely course through this unseen, ghostly landscape. Let us try to imagine the shape of this journey, not over thousands of years, but over the entire sweep of cosmic time. It is a path of almost perfect, serene simplicity, a single, elegant line drawn across the expanding canvas of the universe. When the rogue black hole was first ejected from its home galaxy, its path was a dramatic, soaring arc, climbing up and out of the galaxy's gravitational well. But once it is free, once it is coasting in the vast, empty space between the galaxies, its trajectory settles into something remarkably straight. The gravitational pull of the distant galaxies is too weak and too uniform to significantly alter its course. It is now a traveller on the open cosmic ocean, its momentum carrying it forward in an unwavering line. Imagine this path as a single, dark thread being woven into the fabric of space-time. This thread represents the centre of its moving gravitational well, a line of pure, focused curvature. In a static, unchanging universe, this line would be perfectly straight, but our universe is not static. It is expanding. The very space through which the rogue travels is stretching, carrying the distant galaxies further and further apart. So, the path of our rogue is a straight line drawn on a slowly expanding surface. It is like drawing a line with a pen across the surface of a balloon while it is being gently inflated. The line itself is straight, but the space it crosses is constantly growing. This means that its journey is not just a journey through space, but a journey with the expansion of space. Over billions of years, this lonely path would stretch to unimaginable lengths. It would be a graceful, almost featureless trajectory connecting its distant past, that brief, violent moment of its birth in a chaotic stellar dance, to a future it may never truly reach. It might pass through the outskirts of a few distant galaxy clusters, its path slightly deflected by their immense gravity, but for the most part, its journey is one of profound isolation. There is a sense of purpose and inevitability in this image. The black hole is not wandering aimlessly, it is following the precise path dictated by its initial ejection. Its entire future was determined in that single chaotic instant. It is a memory of that moment, expressed as a straight line across the cosmos. It is a thread of distorted space-time, a silent testament to a gravitational story that ended billions of years ago. What this really means is that the journey of a rogue black hole is an expression of pure inertia. It is the embodiment of Newton's first law of motion on a cosmic scale: an object in motion stays in motion. It is a concept of profound simplicity and elegance, a quiet and unwavering constant in a universe of constant change. It is a path of such purity that it forces us to ask the ultimate question about any journey. Where does it end? What is the final fate of this eternal, lonely traveller? What is the final fate of this eternal, lonely traveller? Where does this long, straight and silent path ultimately lead? The answer lies in the deepest and most distant future of the universe, a future so far from now that our current cosmic era will seem like a fleeting dream. The ultimate fate of a rogue black hole is a story of almost infinite patience, ending in a final, quiet whisper. As our rogue continues its journey for trillions upon trillions of years, the universe around it will become an almost unrecognizable place. The expansion of the cosmos will have accelerated, pushing all the distant galaxies so far away that their light can no longer reach us. The sky will be almost completely dark, the great cosmic web of galaxies having been stretched to the breaking point. All that will be left in our local corner of the universe will be the cold, dead remnants of stars, white dwarfs, neutron stars, and other black holes, all slowly circling the black hole at the center of what was once our galaxy. Our rogue wanderer will be truly and utterly alone in this dark, empty future. It will drift through a void so profound that it may never encounter another particle of matter for the rest of its existence. Its journey, once a path through the universe, will become a state of perfect isolation, its binos, within the universe. It will be a self-contained entity, a lonely island of curved space-time in an endlessly expanding flat ocean. But even in this state of perfect isolation, it is not entirely eternal. According to a revolutionary idea proposed by Stephen Hawking, black holes are not completely black. They have a temperature, and they glow, ever so faintly. This is Hawking radiation. Through a subtle quantum effect at the edge of the event horizon, a black hole slowly, atom by atom, radiates its own mass and energy back out into the universe. This process is unbelievably slow. For a stellar mass black hole, the time it would take to evaporate completely is staggeringly long, something like 10 to the power of 67 years. It is a number so vast that it is meaningless in human terms. It is a timescale that makes the current age of the universe seem shorter than the blink of an eye. But the universe has time. And so, over these truly cosmic, almost unimaginable eons, our rogue black hole will slowly shrink. It will radiate its energy away in a gentle, constant stream of faint particles. It will be a slow, quiet, final exhalation. The information it consumed, the stories of the stars and asteroids it swallowed, may be slowly and complexly encoded in this final, faint whisper. In its final moments, as it shrinks to the size of a single atom, the evaporation process will accelerate, ending in a final, tiny flash of light and energy. And then it will be gone. What this really means is that the journey of the rogue black hole, which began in a moment of gravitational violence, ends in a moment of quiet quantum peace. Its mass, its energy, its entire being is returned to the universe. It has completed its long, lonely cycle. It was born from a star, became a point of pure gravity, wandered the cosmos for an almost infinite lifetime, and in the end dissolves back into the fundamental energy from which all things are made. Its long, straight path across space-time finally comes to a gentle, quiet end. The wanderer has, at last, found its final rest. The wanderer has, at last, found its final rest. And in contemplating its immense and lonely journey, from chaotic birth to quiet dissolution, we begin to see the universe in a new light. The story of the rogue black hole reveals that the cosmos is not a static, clockwork machine, a perfect and predictable crystal palace of stars. It is something far more dynamic, more organic, and in many ways, more interesting. It is a wild garden. A perfect machine, once set in motion, follows a predictable path. Its gears turn, its levers move, all according to a pre-written plan, but a garden is a place of constant, unpredictable change. Seeds are scattered by the wind, not by a blueprint. Some land in fertile soil and grow, others land on stone and do not. Plants compete for light. A storm might come and change the landscape in an afternoon. It is a place of accident, of exile, of unexpected creation, and of slow, inevitable decay. The journey of our rogue is a perfect illustration of this wilder, more organic cosmos. It was not born by design, but by a chaotic, unpredictable gravitational accident. Its path was not chosen, but was thrust upon it. It is a seed of gravity, scattered into the void. On its journey, it becomes an agent of both creation and destruction, again, not by intention, but by chance. It accidentally triggers the birth of new stars in a nebula, like a fallen log in a forest, creating a fertile patch for new growth. It gently perturbs the comets of a distant solar system, sending a slow, beautiful rain of ice into its heart. It might even, over eons, gather enough cosmic dust to become the seed for a new dwarf galaxy, a wildflower blooming in the middle of a barren plain. This vision of the universe is, perhaps, more comforting than the vision of a perfect, cold machine. It means the cosmos is not a finished object to be admired, but a living, breathing, and constantly evolving system. It has room for randomness, for individuality, for lonely journeys and unexpected consequences. It is a place where a single, exiled object can write a new and unique story in the darkness. What this really means is that our sense of place in the universe is subtly changed. We are not just cogs in a grand machine, but inhabitants of a wild and beautiful garden. There is an element of the untamed in the cosmos, a sense of freedom and unpredictability. The rogue black hole is the ultimate embodiment of this wildness. It is the wolf of the cosmic forest, the lonely hawk circling in the empty sky. It follows its own path, governed by its own nature, and in doing so, it changes the landscape around it in ways that are both subtle and profound. And seeing the universe this way, as a place of both gentle stability and wild, unpredictable journeys, allows us to look back at our own small, quiet corner of the cosmos with a new sense of appreciation and a quiet feeling of profound gratitude. Seeing the universe this way, as a place of both gentle stability and wild, unpredictable journeys, allows us to look back at our own small, quiet corner of the cosmos with a new sense of appreciation and a quiet feeling of profound gratitude. For a moment, let us leave the lonely path of the wanderer and return home, to our own familiar place in the grand scheme of things. Let us feel the stillness of our own cosmic harbour. Here we are, on a small rocky planet, orbiting a stable middle-aged star. Our sun is not a massive giant, destined for a short, violent life and a dramatic collapse. It is a calm and predictable star, one that will burn steadily for billions of years to come. It is a gentle, life-giving hearth. Our solar system is not located in the chaotic, crowded core of the galaxy, nor in a dense star cluster where violent encounters are common. We live in a quiet, suburban spiral arm, a peaceful neighborhood where the stars keep a respectful distance. Our planet's orbit is nearly circular, a steady, rhythmic path that gives us predictable seasons and a stable climate. The other planets in our system are well-behaved neighbors. Their gravitational influence is gentle and rhythmic, holding our own orbit in a state of long-term, delicate balance. And at the heart of our Milky Way, our supermassive black hole, Sagittarius A, sits peacefully. It is not a raging quasar, devouring matter and blasting the galaxy with radiation. It is a sleeping giant, a quiet and stable anchor for our entire galactic family. There is a deep and profound peace in this stability. We are living in a moment of cosmic calm. We are the beneficiaries of a long and unbroken chain of gravitational tranquility. Our existence is predicated on the fact that no rogue wanderer has passed too closely, that our sun has not been part of a chaotic dance, that our galaxy's heart has not been torn out. We are inhabitants of a sheltered bay, while the story of the rogue black hole is the story of the vast, wild and stormy ocean that lies beyond. What this really means is that our own existence is a quiet miracle of stability. The story of the rogue black hole is not a threat to us, but a contrast that illuminates the preciousness of our own situation. By understanding the exile, we can better appreciate the home. By contemplating the wanderer's eternal lonely journey, we can find a deeper sense of belonging in our own steady, circular path. It fosters a feeling of quiet gratitude, not just for the earth beneath our feet, but for the calm gravitational environment that holds us. It is a gratitude for the predictable rising and setting of the sun, for the steady waltz of the planets, for the fact that we are part of a stable system, a cosmic family that has so far remained unbroken. Our home is a place of profound peace, and the stories of the cosmic exiles are the very tales that remind us of how special that peace truly is. It is a peace that allows us to look out into the darkness and find not fear, but a quiet and wondrous beauty in all the things we cannot see. This peace allows us to look out into the darkness and find not fear, but a quiet and wondrous beauty in all the things we cannot see. The journey of the rogue black hole is more than anything a lesson in the profound elegance of the unseen. It teaches us to find evidence of reality, not just in the bright, shining objects that command our attention, but in the subtle, graceful effects that darkness can have on the light. Our senses are drawn to the luminous. We look up at the night sky and see the brilliant pinpricks of stars, the soft glow of the moon, the hazy river of the Milky Way. Our stories and myths are filled with light as a symbol of knowledge, goodness, and life. Darkness, in contrast, is often a symbol of ignorance, of emptiness, of the unknown. But the story of the wanderer reframes this relationship. It shows us that the darkness is not empty, but is filled with a rich and dynamic population of objects whose existence is as real and as important as the stars themselves. The darkness, in this story, is not a void, it is a medium. It is the canvas upon which the subtle art of gravity is painted. We learn to see the invisible black hole by the way it bends and magnifies the light of a star behind it, creating a ghostly Einstein ring. We are seeing the effect to understand the cause. It is like seeing the path of the wind by watching the way it makes the leaves of a tree dance, or knowing the shape of a riverbed by the currents we see on the surface of the water. We are learning to read the language of absence, the grammar of the unseen. This is a skill that requires a different kind of perception. It requires patience. It requires trust in the subtle evidence. It requires us to believe that the universe is far grander and more complex than what is immediately visible to our eyes. The rogue black hole is a quiet teacher, guiding us toward this deeper, more nuanced understanding of the cosmos. It reminds us that reality is layered, and that the most profound truths are often not the loudest or the brightest, but are whispered in the quiet interactions happening just beyond our immediate sight. What this really means is that the universe is a place of beautiful and profound subtlety. The loudest, most energetic events, like supernovas, are only one part of the story. The silent, patient, and invisible journeys of these dark wanderers are another equally important part. They are the hidden architects, the quiet gardeners, the unseen currents that shape the cosmos in ways we are only just beginning to appreciate. Finding beauty in the unseen is not just an astronomical exercise, it is a deeply human one. It is an invitation to look for the subtle influences in our own lives, to appreciate the quiet forces that shape us, to understand that the most important things are not always the most visible. The rogue black hole, in its perfect blackness, becomes a symbol of this profound and beautiful mystery, a mystery that connects its cosmic journey, in a strange and poignant way, to the archetypal stories of our own human experience. The rogue black hole, in its perfect blackness, becomes a symbol of this profound and beautiful mystery, a mystery that connects its cosmic journey, in a strange and poignant way, to the archetypal stories of our own human experience. When we strip away the astrophysics and the cosmic scales, the story of the wanderer is a story we know intimately. It is the story of the exile, the outcast, the solitary traveller on a long and uncertain road. It is an archetype that resonates deeply within our myths, our literature, and our own hearts. Think of the great stories of human history. So many of them are about a figure who, by choice or by force, leaves their home and embarks on a long journey into the unknown. They are cast out from their community, separated from all that is familiar, and must find their way in a world that is not their own. This figure, the exile, is often lonely, often misunderstood, but their journey is always one of profound transformation. In their solitude, they discover a new strength, a new purpose, a new understanding of themselves and the world. The rogue black hole is the cosmic embodiment of this archetype. It was born in the heart of a stellar family, a community bound by gravity. A moment of chaos, of violent and unresolved conflict, cast it out. It was sent on a one-way journey, away from the light and warmth of its home, into a cold and lonely darkness. Its journey is silent, solitary, and seemingly endless. And yet, as we have seen, this lonely traveller is not merely a passive victim of its fate. It becomes an agent of change in the universe it passes through. It carries its own immense gravity, its own centre, with it. It is not defined by the home it lost, but by its own intrinsic nature. It becomes an accidental creator, birthing new stars in its wake. It becomes the heart of a new, dark family, capturing an orphan planet and its moons. It becomes a seed for a new galaxy in the distant future. In its profound exile, it finds a new and unexpected purpose. There is a strange and poignant kinship we can feel with this silent wanderer. We all, at times in our lives, can feel a sense of being an outsider, of walking a lonely path. We all understand the feeling of leaving a familiar home behind and stepping into the unknown. The story of the rogue black hole reflects our own capacity for resilience, for carrying our own centre of gravity within us when the world around us feels distant and unfamiliar. It is a cosmic mirror to our own solitary journeys. What this really means is that the universe tells stories that are fundamentally human. The laws of physics, in their impartial and elegant unfolding, create narratives of loss, of endurance, of transformation, and of unexpected creation. The rogue black hole is not just a scientific object, it is a character in a grand cosmic epic. By following its story, we are not just learning about the universe, we are learning about a pattern of existence that is woven into the very fabric of our own being. It teaches us a new and more profound definition of what it means to be home. This cosmic epic teaches us a new, more profound definition of what it means to be home. We tend to think of home as a fixed place, a physical location, a house, a city, a planet, a galaxy. It is a stable harbour, a point of return, a centre to which we are tethered. Our own Earth is a perfect example of this idea of home, a bright, warm, predictable haven in the vastness of space. But the journey of the rogue black hole challenges this definition and offers a quieter, more internal alternative. For the rogue wanderer, home is not a place it can ever return to. The home it once knew is gone, a fading memory of light shrinking in its past. Its journey is not a circle, but a straight line leading into an unknown and ever-expanding future. It has no external anchor. It has no community to belong to, and yet it is not lost. It is not without a center. Its home is the very center of gravity that it carries within itself. Imagine that for a moment. The black hole's entire reality, its entire sphere of influence, is generated from its own being. The immense curvature of space-time, the pocket of the distorted time, the inescapable event horizon, all of these are properties of the object itself, not of its location. It carries its own reality with it wherever it goes. Home, for the rogue, is not a destination. It is the path itself. Its purpose is found not in arriving, but in the silent, steady act of journeying. This is a powerful and deeply meditative concept. It suggests that our own sense of home, our own center of gravity, can also be something we carry within us, rather than something we must find in the external world. It is a reminder that even when we feel adrift, exiled, or on a lonely path, we are always at the center of our own experience. We carry our own stories, our own memories, our own unique way of shaping the world around us. The rogue black hole becomes a symbol of ultimate self-reliance, of finding a profound and unshakable peace in one's own nature. It does not strive, it does not struggle against its fate. It simply is, and in its being, it follows the path laid out for it with a kind of cosmic grace. It is a silent meditation on finding our center within ourselves, on understanding that our journey is our home. What this really means is that our exploration of this cosmic wanderer has brought us full circle, from the vast and impersonal scales of the universe, right back to the quiet, intimate landscape of the self. The story that began with chaotic physics and celestial mechanics has become a gentle philosophical reflection on our own place in the world. It reminds us that the universe is not just something to be observed from a distance, but something whose patterns and stories are reflected within us. The silent wandering ghost, in the end, shows us a path to finding our own quiet center, a home that can never be lost because it is a part of who we are. And so, we return to that single lonely traveler to hear the final notes of its quiet cosmic lullaby. And so, we return to that single lonely traveler to hear the final notes of its quiet cosmic lullaby. Let us bring our focus back to one solitary rogue black hole, gliding silently through the deep and patient void. Let your mind drift with it for a moment. Feel the profound stillness of its journey. There is no up or down, no wind or weather, only the silent, steady coasting through the expanding fabric of space-time. Behind it, billions of years in the past, lies the memory of its violent birth, the chaotic dance in a star cluster that sent it hurtling into the darkness. Ahead of it lies a future of almost unimaginable length, an eternity of travel that will end only when the universe itself has grown old and cold, and the black hole dissolves in a final, quiet whisper of radiation. But for now, in this long, extended moment that is its life, it simply travels. We don't know where it came from, not really. We can imagine its origins, but we can never point to a specific star in a specific galaxy and say, that was its home. We don't know where it is going. Its path is a straight line to infinity, a journey without a destination. Its existence is not about its origin or its final end, but about the journey itself. The journey is its entire story, its entire purpose. There is a deep and calming peace in accepting this mystery. We don't need to have all the answers. In fact, the story is more beautiful because we don't. The rogue wanderer becomes a gentle, calming presence in our cosmic imagination, a symbol of the great, quiet, and unseen universe. It is a reminder that the cosmos is filled with stories that are happening right now, stories of solitude, of endurance, and of silent, graceful motion, all playing out in the dark, far beyond our sight. Let the image of this silent wanderer be a source of peace for you now. Let it be a quiet companion as you drift towards sleep. It is a point of perfect blackness, a moving pocket of stillness. It is the calm at the heart of the cosmic storm that created it. It asks nothing of you, demands nothing. It simply is. And in its steady, silent passage, It offers a lullaby of pure, unwavering motion, a song of gravity and time, a gentle hum that resonates with the quiet rhythm of your own breathing. What we have found on this journey is not a set of neat answers, but a deeper and more profound appreciation for the mystery. We asked what happens when a black hole goes rogue, and the answer we discovered is a story. It's a story of exile and creation, of loneliness and purpose, a story that is both epic and incredibly beautifully quiet. We asked what happens when a black hole goes rogue, and the answer, we discovered, is a quiet and endless story. It is a journey that teaches us about the gentle ocean of space-time, about the silent surrender of a dying star, and about the beautiful unseen dance of gravity. It shows us a universe that is not a perfect machine, but a wild and wondrous garden, a place of accidental creation and graceful lonely paths. We followed a ghost into the dark, and we found not a monster, but a quiet wanderer, a cosmic exile that carries its own home within itself. Its story is a soft echo of our own human tales of leaving home, of finding strength in solitude, and of the quiet resilience of the spirit. And now, it is time to let that story go. It is time to let the silent wanderer continue on its path, to let it fade back into the deep and peaceful darkness from which it came. The questions have been asked, the journey has been taken. All that is left now is the quiet stillness of the night. So let your own thoughts begin to wander and drift. Let them become as quiet and as distant as the farthest galaxies. There is nothing left to do now but to rest. Thank you for joining me on this journey through science and slumber. I hope it has brought you a sense of peace and a touch of wonder. May your sleep be deep and your dreams be filled with silent, beautiful stars. Good night.